Okay, so we have a function here. 1 over f is 1 over u plus 1 over v. U and v are measured to be 50 and 200 millimeters with these uncertainties. So from this formula, we can tell that the maximum possible value of f happens when u is maximum. So 53 mm is the maximum possible value for u, and maximum possible value for v is 205. From here you get f max to be 42.1 mm. Likewise, the minimum possible value for f occurs when both u and v are having their minimum possible values. So I'm going to write the minimum possible value for u, which is 47, which I get from 50 minus 3. And on the other side, for v, I'm going to write 195. So the minimum possible value for f is 37.9 mm. So the values of f actually range from here to here. So how should we express the uncertainty in f? Very easy. Just take the maximum minus away the minimum divided by 2. So roughly, the uncertainty is about 2.1 mm. Okay, I know that there are many students who actually tried to solve this question the algebraic way and they still end up with the wrong answer. Let me try to think what they do. Okay, they'll first rearrange this equation. They'll make f the subject and they'll end up with uv over u plus v. And the next thing they say is the fractional uncertainties in f should be equals to the fractional uncertainties in uv plus the fractional uncertainties in u plus v. And of course they will further break this down into this, and then they'll sub in the numbers and they'll get a different answer. So what's the problem? Okay, to understand the problem, you got to recall the underlying assumptions for this rule. So let's say something is a divided by b, and so we have this rule that says that when it's multiplication or division of terms, we can just add up their fractional uncertainties. But you have to realize the underlying assumption. So for example, when does the maximum possible value of x occur? It occurs when a is at the maximum but b is at its minimum. That's when we get the maximum value of x. Alright, and because of that, we can simply add up the fractional uncertainties in a and b. But let's look at this case here. When do we get the maximum possible value of f? If you just think very simplistically, you're going to say, when uv is maximum and when u plus v is minimum. The problem is these two terms are not independent of each other. So when you try to make uv maximum, I suppose by making u as big as possible, then you're not able to make u plus v as small as possible. Right? They're dependent. They're not independent of each other. So in this situation, then the next line that's written here is wrong. It's not valid anymore. In order to do something like this, all the terms has got to be independent of each other. Okay? So yeah, actually this method is pretty good. It's applicable for all cases. So, yep. Remember there's such a way, alright?